All right, good morning, students. Hopefully you're doing well. I've developed our final project or activity, okay, for gases that we've been working on, and it's our hydrogen gas lab. So I'm hoping that you really spend time on this and do your own work as much as you possibly can. I have this video answer key to help you. So this should tie a lot of ideas together in for you. So spend time on it and it'll be worth the while. Okay, pre-lab questions. A gas is in a rigid container, so volume cannot change. Okay, the temperature is increased, so what should happen for the pressure of the gas? Well, that means the molecules are now moving faster, they're colliding more frequently and more force with themselves in the container. So we're expecting this to increase. So pressure should increase. All right, next question. A gas is held at constant temperature when its volume increases. What should happen to the pressure? Well, because now there's more space for the molecules to exist in, they should collide less often. So we expect to see a decrease in pressure here because of that more space. Okay, next question. A gas expands at constant pressure. What should happen to the temperature? Well, in order to allow gas molecules to move farther apart and move faster, we would expect that the temperature needs to increase for this one in order to allow that volume expansion to occur. All right, next one. A gas is in a rigid container, so the volume cannot change when more gas molecules are added to the container. What should happen to the pressure? Well, imagine, you're in a room and all of a sudden a lot more people come in. That'll definitely increase your pressure, wouldn't it? Okay, so now there's more molecules in there. They're bouncing off each other more frequently, and that would increase the pressure. All right, let's move on to some calculations. These are some gas laws to review that will help us with this lab. A gas at initial volume of 3.4 liters has a pressure of 86.7 kilopascals. What's the new pressure if the volume expands to 5.6 liters? Well, this is Boyle's law. Pressure 1, volume 1 equals pressure 2, volume 2. All right, so I'm just going to put my variables in. So 86.7 is pressure 1. Okay, put my decimal there. And 3.4 liters is my beginning volume. Equals, I'm trying to find pressure 2. Okay, and I'll multiply that by 5.6 liters. All right, I need to get pressure 2 by itself, so I'm going to divide by 5.6 on both sides. So I'm taking 86.7 times 3.4 divided by 5.6, and my new pressure 2 equals 52.6 kilopascals. Okay, hopefully that made sense. And we're just going to move along here. Convert 25 degrees to Kelvin. So I'm going to do 25 plus 273. Okay, and that's going to equal 298 Kelvin. Okay, that's pretty easy to do. Just a reminder, all degrees Celsius must be in Kelvin. A gas has an initial volume. Now I'm going to write everything down here. So I've got a pressure 1 here listed of 94.4 kilopascals. My initial volume 1 is 7.8 liters. An initial temperature of 35 degrees Celsius. So that's temperature 1. So that's going to be 35 plus 273. And that is going to be equal to 308. Okay, and that of course is Kelvin. All right, determine its volume at STP. So that's going to then be pressure 2, well, at standard temperature pressure. So that's 101.3 kilopascals. That's the kilopascals, okay, for 1 atmosphere. Volume 2 equals a question mark. We don't know. That's what we're solving for. Temperature 2 is going to equal 273 Kelvin. So there you go. Now we'll need to calculate that out. Okay, so this is going to be the combined gas law. Pressure 1, volume 1, temperature 2 equals pressure 2, volume 2, temperature 1. Okay, let's go ahead and plug everything in. That would be 94.4 multiplied by 7.82. Okay, now we're going to put temperature 2 there of 273 equals, okay, what's our pressure 2? 101.3. Okay, volume 2 is what we're trying to find. And temperature 1 was 308, okay, Kelvin. Okay, so now mathematically, what do we need to do here? So we need to get volume 2 all by itself. So I'm going to divide both sides. Now remember to parentheses this in your calculator. So I'll go 101.3, and I'll hit the times button, times 308. All of that's in parentheses. So I'm going to divide this side here by that as well. So 101.3 times 308. Okay, now this volume here, I actually put the liters in there, so I'm just going to kind of X that out of there. That's 7.8. You shouldn't put the liters in there. Okay, so when you take 94.4 times 7.8 times 273 divided by parenthesis 101.3 times 308, you will get 6.44 liters. Okay, so hopefully that made pretty good sense. Now I put another question right underneath there, pretty close. We're going to do this one here. Determine the volume of 1.4 moles of a gas that's at 25 degrees Celsius and has a pressure of 87.7 kilopascals. Okay, well that one is going to be a pressure volume equals nRT equation. That's the Pivnert equation. Okay, so I'm just going to place the variables right underneath there so that you can see it. So we determine volume of 1.4 moles of a gas, and the pressure is 87.7. So I'm going to put 87.7 here. Volume we don't know, equals, we've got 1.4 moles. The R value is 8.31. Okay, because we're in kilopascals, the other R values for atmospheres, and then multiply by 25 degrees Celsius, which we know is 298 Kelvin. Okay, and now it'll be our job to determine the volume. Okay, now let me extend the page here a little bit. To get the volume of that, I'm just going to divide both sides by 87.7. That'll get my volume by itself. So I'll take 1.4 times 8.31 times 298. Okay, and our volume is going to equal, and volume 2 is equal to 39.5 liters. All right, hopefully that made sense. Now our final question is going to get us a little bit more ready, okay, for the lab that we're going to be doing. Okay, so a reaction with aluminum and hydrochloric acid, which is HCl, to produce aluminum chloride and then hydrogen gas. And this is our chemical reaction we're dealing with. Okay, so it gives us the conditions of everything here, the vapor pressure, because this is collected over water. Okay, and the first step is to determine the moles of hydrogen gas produced using two-step stoichiometry. So I'm going to be starting with my grams of my metal, 0.055 grams of aluminum. And I'm going to do a two-step to try to get over here to moles of hydrogen gas. So I'm going to first of all get this in the moles, so times by 1 mole of aluminum. And I'll go to the periodic table to get the atomic mass for this, which is 26.9815 grams of aluminum. And now my next step is going to be looking at my balanced chemical equation. So I need to get moles of hydrogen. So I look up here, I see there's a 3 there. So I know I've got 3 moles of hydrogen. Notice how I put this one on top, and I got to use that number. And then aluminum will be on the bottom because it's what I have over here. I look over there, I see that there's a 2 there. So that's going to be over 2 moles of aluminum. Okay. And I'm going to take 0.055 divided by 26.9815 times 3 over 2, and my moles of hydrogen equals 0.00306. All right, now step 2. This gas is collected over water. So I will have to use Dalton's law of partial pressures to get the dry hydrogen pressure. Okay, so I'm going to take 98.5 minus, and I need to find my vapor pressure water, which is right there. So it's 3.17. So it's just a simple subtraction. Here's my wet hydrogen pressure. Here's my dry. Just subtract the two of those. And my dry pressure is 95.33 kilopascals. Now it says use the ideal gas law to determine the expected volume of dry hydrogen produced. Okay, so now I'm back to PV equals nRT. Okay, now we'll have to assemble things from a variety of places here. My pressure is going to be this one. So 95.33. I have to use my dry pressure because I want my volume of dry gas times volume there equals N, which I calculated up here to be 0.00306. My R value again is 8.31 because I am in kilopascals. And my temperature, 25 degrees Celsius up here, which is 298 Kelvin. Okay, so where did I get all those values from? I'll use a different color. I got my pressure from here, my moles from here, R constant because I'm in kilopascals. My 298 is coming from my 25 degrees Celsius here. And my volume produced is going to be 0.0795, and that's going to be liters. Because we always get liters when using the PV equals NR equation. Okay, so there's all of our answers for the pre-lab. Now you can move on to the lab, and this should help you a lot. Okay, and if you need anything, I will answer any questions, and we'll probably be doing a Google Meet for lab. Have a super day.